Hello again and welcome back. In this lesson, I'm going to show you how we use tins in practice. First, I'll show you how we take point data and turn it into a tin, and then we'll create a raster from the tin, and then we'll load it up in a viewer called ArcScene that's similar to ArcMap that we can use to see it in 3D. So first, we have a lot of point data in here. These point data were captured by an instrument called LiDAR that some of you might be familiar with, but many of you won't be. LiDAR is similar to radar in that we bounce electromagnetic waves off of things and then see how long they take to return, and that helps us determine their distance. But in LiDAR's case, we use light to do it rather than your standard longer waves of radar. This can generate a lot of data. So if we try to measure the distance between some of these points, it's really small. It's maybe a meter oftentimes. And so there's a ton of data over the landscape. We're not looking at a very large area here. And that makes LiDAR really good for capturing true terrain data because we get a lot of data of what's happening on the landscape, and then we can create good terrain data sets from that. And that's what we'll do. As background, I downloaded this data set for free from a viewer in the US called the National Map, where various agencies submit their data for download from the general public. So this is covering a part of Marin County in the Point Reyes National Seashore and Golden Gate National Park. And I was able to obtain this data set for free online, and you can get much larger areas out of that as well. So to get going, let's create a tin out of this data set. While I'm bringing that up, this data setup I did was simply bringing it into ArcGIS as a Lays data set. I created a Lays data set, which I won't show you here, but just so you have kind of a sense of the steps I took to prepare it in the background. I created a Lays data set, I explored the data, and then I used a tool called Lays, which was the LAS is the file type that LiDAR data often comes as, lays to multi-point to create this point data set here that I'm using. So just so you know, there's a little data setup that goes into this, and that maybe you'd be able to find that yourself too. But that's not the main objective of this. So what we're going to do now is we're going to create a tin from our points here. So to begin with, we'll go to the search and we'll do create tin. And that's a 3D Analyst tool, and it looks like it's in 3D Analyst Tools Data Management, tin, create tin. Great. So I'm going to click on it. Oh, but I haven't enabled the 3D Analyst license yet. So we haven't really used many 3D Analyst tools yet. But just like Spatial Analyst, I'll need to enable that license. So if I click OK and go to Customize Extensions, I can enable 3D Analyst, and I'll enable Spatial Analyst just in case too. And then now we know where that tool is anyway, so go to Data Management, Tin, and then Create Tin. And now I should be able to execute the tool. Okay, and this is another one of those tools where the ordering of the parameters you don't necessarily want to follow because, I mean, depending on your workflow, you might just want to select your input feature class and have it set the coordinate system for you. So in this case, we'll set our points as the input feature class, and we'll note that it set the height field for us. It won't always do that, but because these points are Z enabled, that is they have X, Y, and Z coordinates, it automatically set it to the shapes Z field. If I didn't have that, if I instead had an attribute that was the Z value, I would need to select the height field from here and tell it that that is the field that contains the elevations. So we'll ignore the rest of these options for now and have it use the defaults for everything else, and click OK. And this tool usually runs surprisingly fast. I'm always impressed with exactly how quickly it can generate a tin from this many points. And there it is. It throws it up in the background. And if I turn off the points and I zoom to the tin, it takes it a little bit to render. I'm running on a slower system now than usual. So it can take it a while to fill all this data in. But we'll take just one look at the full data set here, and then we'll zoom into some areas that render faster. But out of this, we get a full terrain model here. I think that's pretty amazing. And ArcGIS does a little bit of a 2.5D sort of thing here and shades this multi-patch sort of feature set here to give us a sense for elevation. It does a bit of a almost like a hill shading approach on it, and then it gives us some hypsometric tinting to tell us what the elevations are with color and kind of contours those. Now here's the whole data set, but if I zoom into a spot, I can see all the triangles in my tin here. That's pretty cool. I can actually see that this really is made up of tons and tons of tiny little triangles here. And spots that have more points have smaller triangles, which makes sense. There are more connections covering that. Now, this lecture will run a little long if I do this too, but I want to show you that if we wanted to, we could create the Thiessen polygons, or the Voronoi polygons, right here, and I could run this tool and overlay them to see that the tins do in fact just cross the Thiessen polygon boundaries. If you're following along on your own computer, I encourage you to run the Create Thiessen Polygons tool in order to see how the points, the triangles, and the Thiessen polygons relate to each other. Okay, so now let's convert this tin to raster. So we'll type tin to raster and see what comes up. And there's a tool for that, tin to raster, in the 3D Analyst toolbox. And we'll provide our tin as an input. And we'll call it the marine tin. And we'll leave it as floating point output so that it can do parts of meters as its elevation. And we'll have it use the standard linear interpolation method and keep all the rest of these as defaults to convert the tin to the raster. I'll click OK. And this one, again, running down here. And when it's done, we get a raster covering our area of interest and a complete terrain model for the area that we just made a tin for. Now I could have set the cell size too, but I left that as the default. So we could potentially create a higher resolution tin, but whether or not we're actually getting, or higher resolution raster, but whether or not we're actually getting real data out of that isn't totally certain. Because if we set the tin to create a higher resolution raster, that might be higher resolution than the tin's observations actually lend themselves to. So this is good enough and looks like a good elevation surface. It's pretty amazing that you can create this just from points in such a short amount of time by creating a tin and then creating the raster out of it. And the last thing I want to do is bring up the 3D Analyst toolbar, and we're going to launch ArcScene. And ArcScene is where we can visualize the 3D information in 3 dimensions. So we've been visualizing it all in 2 dimensions right now, but we'll actually load it up in 3D. So I'll use the default, and ArcScene, I'll give you an overview of it in a later lecture, but ArcScene looks a lot like ArcMap, and in fact it uses a lot of the same paradigms. So I'm not going to explain everything to you, but know that it's ArcMap but meant for 3D editing workflows and 3D viewing workflows. And this will set you up nicely for using ArcGIS Pro, because ArcScene is sort of the 3D component and ArcMap is the 2D component, and ArcGIS Pro integrates those into one application. So once we get access to that with these courses, you'll be able to understand what's going on in ArcGIS Pro as well. So I was going to drag the tin across here, but I remembered that I can't do that. So let's make ArcScene the full thing here. And then I'll go to Add Data. And I forgot to give it a good name, so it's named Create Tin, but we'll add that. It's adding it in the bottom right corner here. So it loads it up and gives us a perspective view right off the bat. And notice that I have the Navigate tool active here. So if I use my mouse, I can actually move around this thing in 3D. And again, this computer is a little slower. It doesn't have hardware acceleration, so it's a little clunky, but on most computers this should move a little faster than it often will on my screen right now. And you can explore this terrain surface this way. The other cool thing is that ArcScene has a sense for elevation surfaces. So if I make this an elevation surface by going to Properties and then Base Heights and then floating on a custom surface of itself, that's what it did by default. It understood it was an elevation surface. But I can then add that rivers layer that I was using. And by default, we might not see them very well. So I'll make them a little thicker, and then let's zoom to them and see where they are. Okay, so they're not on the terrain, but what I can do is go to Properties on those and go to the Base Heights tab again, and it says no elevation values from a surface, but what I can do is say it floats on a custom surface. And it looks like I made a mistake here. When I created my tin, I didn't set the coordinate system, and so now they're not overlapping. So for the demo, let's just make a quick fix of this. What I would really need to do is I'd need to go use the define projection tool that you'll learn about later in this course in order to set the projection information. I know that this data is in UTM zone 10 north, and I'd need to set the projection on this data set in order to give it that information that's required. But for now, we can make ArcScene understand where it is, and I'll cancel out of here. And I'll go to Scene Layers as the data frame here, I'll go to Properties, and I'm going to set the data frame to UTM, and I'll search for it, and I know that this is from the same projection that the points came in, so that's why I'm using this projection. So I'm selecting NAD 1983, UTM Zone 10 North, clicking OK, and this projection information will make a lot more sense later in this course. And it's rebuilding the scene. And what that's going to do is it's going to interpret the not specified projection of the tin as if it's in UTM zone 10 north, because that's the projection of the data frame. And at the same time, it's reprojecting the rivers layer into UTM zone 10 north, and now they overlap. So back to the point at hand, if I go to properties, I can set the base heights of any other layer to float on a custom surface as if they sit on top of a terrain layer that I have, such as this tin. So if I click OK, all of a sudden those rivers appear right on top of my terrain layer here, where before they were kind of below it, which maybe was a little hard to see, but they were sticking out both ends and they were hidden by the terrain. Okay, that's it for this lecture. In this lecture, I showed you how to build tins from point data sets, how to turn those back into rasters that you could use as digital elevation models, and then how to bring a tin into ArcScene to view in 3D. In the next lecture, we'll go over ArcScene in a little more detail so you know what you can do with it. I always think it's really fun to visualize my data in 3D, and I hope you enjoy it. See you next time.